So that's what we hope to demonstrate later this year, maybe as soon as 2 or 3 months from now.
Starship Flight 9 doesn't exactly seem like a loss, because right after the flight, Elon Musk and SpaceX immediately revealed solutions to the failures of Starship V2. Even more astonishing is that these solutions are now being integrated into the company's next-generation Starship. So, what are these solutions and how do they work to fix the previous issues? Let's find out in today's episode of Alpha Tech. On May 29th, Elon Musk delivered a speech inside SpaceX's massive Starfactory and unveiled all the upgrades coming to the new version of Starship. Clearly, these improvements are intended to help Starship achieve a new milestone on its journey toward fulfilling the Mars ambition. The first major point discussed was the upgraded Raptor 3 engine. Just before Starship Flight 9, SpaceX had announced future upgrades to Starship will introduce the Raptor 3 engine, which will include additional reliability improvements to address the failure mechanism. Well, this seems to promise innovations we may have never even imagined. Elon Musk appears to have placed great expectations on this new engine, with technical upgrades that he described as an alien engine, operating at a level of performance never achieved before.
So in order to make the engine like that, we had to simplify so many parts of the design, incorporate secondary fluid circuits and electronics in the structure of the engine itself. So everything is contained and protected. It is a marvel of engineering, frankly.
Indeed, the Raptor 3 will be integrated into Starship version 3, bringing significant improvements over the Raptor 2 engine used in version 2. Raptor 3 delivers a thrust of 269 tons at a chamber pressure of 350 bar, compared to Raptor 2's 230 tons, sea level, and 258 tons, vacuum. By eliminating the need for an engine heat shield, Raptor 3 reduces mass and enhances reliability, allowing minor fuel leaks to dissipate harmlessly into the plasma flow during re-entry. Elon Musk highlights Raptor 3's simplified design, integrating secondary fluid circuits and electronics within the engine structure, which boosts efficiency and reduces potential failure points. These advancements enable a super heavy booster with 33 engines to achieve up to 9,000 tons of thrust, minimizing engine-related failures. The lack of a heat shield also simplifies maintenance, supporting rapid reuse, as true to the name, revolutionary engine for its mass reduction and reliability improvements. The next improvement mentioned by Elon Musk is the upgraded heat shield. As we all know, the heat shield has remained a major challenge for the Starship program. Musk expressed during the conversation,
So then with one of the toughest problems to solve is the reusable heat shield. So no one has ever developed a truly reusable orbital heat shield. So it's extremely difficult to do so. Even the shuttle's heat shield required several months of refurbishment.
But it seems that SpaceX is never giving up on building a heat shield that can be rapidly reused hundreds of times, as Elon Musk has strongly affirmed. To address the damage observed in the heat shield on version 2, Starship V3 features a redesigned heat shield with smoother, more streamlined contours and no raised tiles. The forward flaps are repositioned leeward, closer to the nose, and are made thinner and angled to reduce their exposure to re-entry plasma, mitigating the damage seen in earlier flights. The primary heat shield consists of 18,000 hexagonal silica-based tiles, complemented by an improved secondary ablative layer, likely pyron-based to enhance durability. SpaceX is also exploring the use of retro-propulsive entry, using Raptor 3 engines to potentially reduce reliance on the heat shield, simplifying the reuse process. These changes are aimed at creating a reusable heat shield capable of withstanding both Earth and Mars re-entries, where Mars's CO2 atmosphere presents unique oxidation challenges. The third solution featured in SpaceX's new version of Starship is the increased fuel capacity and the addition of more engines. The new version, known as Starship V3, will be extended by about 20 meters, bringing the total stack height to approximately 142 meters. This extension increases the fuel capacity to around 4,000 tons, up from 3,700 tons in V2. The upper stage will feature 9 Raptor engines, 6 sea level and 3 vacuum compared to V2's 6, boosting thrust and enabling a payload capacity of 200 tons reusable, 400 tons expendable, to low Earth orbit. Combined with Super Heavy, Starship version 3 will have a total of 42 engines. Elon Musk confirmed,
The answer to the meaning of life is 42. And so inevitably, the Starship stack will have 42 engines.
greater propellant capacity and thrust reduce the number of refueling launches required for Mars missions, potentially from 8 to 5. The next upgrade for Starship V2 is a new design for the tanks and the connection between Starship and the booster, commonly referred to as hot staging. Elon Musk spoke confidently about this.
So we're developing some next-generation Starships, which have a number of improvements versus our current gen. So it's taller, for example, and has a better the interstage between the ship and the booster. You can see that sort of the sort of struts there. That makes it easier for the flame, like that right there.
The new hot staging design resembles the 3D concept models of Starship shown earlier in 2024, and in fact, it's inspired by the Soviet Union's N-1 rocket hot staging mechanism. With this new design, Elon Musk emphasized the additional protection it offers for the propellant tanks, shielding them from the intense pressure of the Raptor engines during stage separation.
When doing hot staging, which is when we light the ship's engines while the booster's engines are still firing, the flame from the ship engines can more easily exit through the open struts of the new interstage. And in this case, we'll bring the struts interstage back with us instead of throwing it away.
Additionally, the V3 design also includes an elliptical common bulkhead for propellant tanks, optimizing capacity and structural integrity. These upgrades minimize the risk of propellant leaks, preventing ignition issues and enhancing mission reliability. One major issue that is expected to be resolved in the upcoming version of Starship is the upgraded control system. To address the tumbling problem observed during Starship V2's Flight 9 re-entry, SpaceX is introducing enhanced control mechanisms in Starship V3. These include backup control systems and adaptive algorithms designed to maintain stability during the high-stress conditions of atmospheric re-entry. The forward flaps have been redesigned, moved leeward, made thinner, and angled to reduce exposure to re-entry plasma and improve maneuverability. Combined with an increased engine count, now 9 Raptor engines, this provides significantly greater control authority. Elon Musk emphasized the importance of reliable control for achieving precise tower catches, which are essential for rapid reusability. Additionally, we can see notable improvements to the radar systems mounted on the launch tower's chopsticks, which now allow for more accurate tracking during booster and ship recovery. Of course, with the increased height of Starship version 3, the infrastructure also needs to be upgraded accordingly. Starship V3's increased size, with a total stack height of approximately 142 meters, necessitates significant infrastructure upgrades. SpaceX is developing a new launch tower and orbital launch mount, with updated quick disconnect fittings to accommodate V3's dimensions and support a higher launch cadence. SpaceX is constructing a second launch tower at Starbase, Texas, and another in Florida to facilitate these operations. Additionally, the Starfactory facility is being expanded to enable mass production of V3 ships at a rate of 1 every 2 to 3 weeks, with an ambitious target of 1,000 ships per year. When this upgraded infrastructure operates smoothly, SpaceX will be able to achieve ambitious goals such as weekly launches by mid-2026 and support the mass production of starships necessary for Mars colonization, ensuring scalability and operational efficiency. Finally, and perhaps most importantly, is the upgrade in the method of orbital propellant transfer. The orbital propellant transfer is a critical technology for Starship V3's Mars missions, with a demonstration planned for 2025. Elon Musk himself acknowledged this, saying, "Then one of the other technologies that's key for Mars is doing orbital propellant transfer. Of course, this is a highly complex technology, one that no one has ever successfully demonstrated. But SpaceX and Elon Musk remain determined to find a way to transfer cryogenic liquids into space. With the upgraded thrust capacity of Starship V2 around 4,000 tons, combined with an improved docking system inspired by the successful Dragon capsule's connection with the International Space Station, in-orbit refueling from one Starship to another will become possible. So, what about the number of launches required for refueling? To be frank, Starship V2, along with all the upgrades we've discussed, will reduce the number of launches needed to fully fuel a Starship for interplanetary missions and shorten the turnaround time between flights, meaning Starship's reuse rate will increase dramatically. This orbital refueling demonstration is something Elon Musk hopes will happen as early as next year. All these changes ultimately aim to create a unique and unparalleled vehicle capable of realizing the ambitious goal of colonizing Mars. The coming years will mark crucial milestones for SpaceX to strengthen this vision and bring humanity closer to deep space exploration. In fact, Elon Musk, the billionaire entrepreneur, has previously stated that he plans to reduce his involvement in government affairs to focus more on his various businesses, including SpaceX and the electric vehicle and battery manufacturer Tesla Inc. Musk acknowledges that his latest timeline for reaching Mars depends heavily on whether Starship can overcome several challenging technical hurdles during its test flight development, especially the in-orbit refueling maneuvers after launch. Late 2026 coincides with a rare window that occurs every 2 years when Mars and Earth align closely around the Sun, offering the shortest journey between the two planets, taking about 7 to 9 months for a spacecraft to travel there. Musk has given his company roughly a 50-50 chance of meeting this deadline. If Starship isn't ready by then, SpaceX will wait another 2 years before trying again, he suggested in a video. The first flight to Mars is expected to carry a simulated crew made up of one or more humanoid robots designed by Tesla, called Optimus, with human crews following in the second or third landing missions. Musk envisions eventually launching 1,000 to 2,000 ships every 2 years to rapidly establish a sustainable, long-term human settlement. Meanwhile, NASA is aiming to return humans to the Moon aboard Starship as early as 2027, more than 50 years after the last crewed Apollo landing, as a stepping stone towards sending astronauts to Mars in the 2030s. Breaking news: Elon Musk just unveiled a completely new concept for the hot staging ring, one that's poised to redefine the whole Starship's future. The SpaceX CEO announced that the ring is undergoing some major changes, and it's not just about how it looks or how it works. This redesign aims to make the whole system safer, more reliable, and absolutely key to Starship's full reusability. Notably, this upgrade is indispensable for the big Mars mission that the company plans to kick off starting in 2028. So, what makes this new design a total game changer? Why is this ring a make or break for Starship's success? The Starship's hot staging ring might not look like much, but it plays a big role. It sits right between the Super Heavy booster and Starship, built to take a serious beating. We're talking blazing heat, crushing pressure, and total chaos when the upper stage fires its engines before separating. Sounds impressive, right? And yeah, it's a bold piece of engineering. But on Starship's second test flight in 2023, when they used the hot staging ring for the first time, things didn't go perfectly. During separation, Ship 25 fired its engines through the ring just like planned, but only minutes later, Booster 9 exploded during its boost burn. So, what went wrong? The intense exhaust from Ship 25 blasted through the ring's vents and messed up the booster's fuel system. It caused bubbles in the tanks, disrupted the engines, and triggered the rocket's flight termination system. Well, the new part technically did its job, but it also played a part in bringing down the rocket. SpaceX didn't brush that off. They went back, reworked the design, and from flights 3 to 8, the hot staging ring performed more reliably, doing exactly what it was meant to do. By Flight 9, SpaceX appeared to be testing another modification to the hot staging ring. This may have played a role in the explosion of Booster 14 over the Indian Ocean. According to several experts, SpaceX recently added internal plates to the ring to better control how the booster flips during the boost back burn. By sealing off certain sections and restricting the flow of Raptor exhaust, they aim to generate more controlled torque for reorientation. It basically helps the booster turn the right way after stage separation, setting up a good flight path home. Footage from Flight 9 also shows that the hot staging ring had additional shielding plates installed, supporting the idea that SpaceX was actively testing this design change. That said, the exact cause of the explosion remains unknown and will not be confirmed until SpaceX releases an official statement. Following all the issues with the hot staging ring, Elon Musk finally unveiled a brand new design for it during his Mars colonization presentation. This redesign isn't just about looks, it's a mandatory upgrade for the next-gen boosters. It aims to boost staging efficiency, cut down risks seen in earlier flights, and save a ton of time. Why does time matter so much? We'll get there soon. But first, let's check out what's new with the latest upgrade. Here's the new hot staging ring designed for the version 3 booster, and the differences from earlier versions are immediately clear. First, the appearance. This new ring, which I'll call Ring version 3, is built as a lattice of zigzag struts, creating wide-open channels for exhaust gases to escape. Hot gases and shock waves now flow freely downward, reducing pressure buildup and allowing the second stage engines to breathe clean air. Its taller profile also adds an extra layer of protection. Extending above the booster dome, it helps protect critical systems, especially the grid fins, from the fiery exhaust of the ship's Raptors before the gases clear the ring. In earlier versions, those grid fins were sometimes scorched or struck by mechanical shock waves from the flame plume. The larger gaps and open design of version 3 help steer clear of those hazards, shielding the aerodynamic control surfaces and giving them room to do their job properly. Next, an important point. This ring isn't a separate piece that falls off after stage separation anymore. Instead, the support struts are now built right into reinforced mounting points on the booster itself. No standalone ring below. So, basically, the ring has become a permanent part of the booster's structure. This change significantly reduces the time needed for launch pad integration, since there's no longer a separate part to lift and install into position. As Elon Musk said during the presentation, 25 to 25.6.
And in this case, we'll bring the struts interstage back with us instead of throwing it away.
So, during flight, the ring no longer falls away, saving time, money, and effort that used to go into building and recovering a several-ton steel ring. Normally, if it fell into the ocean, SpaceX would simply discard it, like in this photo, where you can see Booster 14 during Flight 9 and the ring falling off. I don't know if they recovered it this time, but in Flight 5, SpaceX had to bring a large recovery ship. I don't even know how they managed to locate it at the bottom of the Gulf of Mexico, where the depth is only around 200 to 600 feet, but you can see they used a pulley system to lift it aboard. As I mentioned earlier, it is very time-consuming. Back to Ring version 3. By making the ring a permanent part of the booster, it can now stay attached during landing. That brings Starship one step closer to being fully reusable. And maybe even more important, the design is way more open. You can literally see the ship's Raptor engines through the ring now. Earlier versions had small exhaust ports to redirect heat and pressure, but they still created enough back pressure to mess with the ship's lower engines. Many engineers believe this engine choking effect contributed to the failures on Flights 9, where Raptors struggled under abnormal exhaust flow. That's why this new version opens everything up. SpaceX says Booster 18, the next in line, will be the first to get the new Ring version 3. It's also getting upgraded domes and redesigned control surfaces. Engineers plan to move it to the Mega Bay for final assembly in the next few weeks. If everything goes as planned, we could see a fully integrated version 3 booster standing on the launch pad before the year ends, ready for its first flight. But this isn't just about looks. The new hot staging ring, lighter grid fins, and reworked domes and actuators all aim to cut weight, speed up refurbishment, and simplify pre-launch and in-flight procedures. Ideally, a version 3 booster would land under its own power, with the ring still intact, get quickly polished up, and be ready for its next mission faster than any rocket ever. I'm really excited to see how it performs on its first real flight. If you want to catch that moment with us, please support the channel by subscribing. We're aiming for 150,000 subs. Thanks so much for your support. Now, let's talk about the pros and cons of this smart design. Besides improving staging efficiency, ease of manufacturing and refurbishment were key focuses for the version 3 ring. Unlike the old ring, which had lots of welds, panel joints, and required post-flight repairs, the new lattice structure is simpler to forge, assemble, and inspect. Each brace is modular and self-contained, so damaged parts can be swapped out quickly without taking the whole ring apart. This matters a lot for Musk's Mars plans. SpaceX aims to launch hundreds, maybe even thousands, of Starships during a 2-week launch window every 2 years. That's roughly 50 to 70 flights per day. Losing a hot staging ring after every flight would be a huge waste. Even if they recover them from the ocean, it needs a dedicated recovery team, which is costly, inefficient, and time-consuming. But these benefits come with some serious trade-offs SpaceX will need to handle. First off, the added dead weight from the integrated hot staging ring increases the mass that Super Heavy needs to carry during its return and landing phase. That means more fuel is required to maintain trajectory, execute the entry burn, the landing burn, and land safely. According to the Tsiolkovsky rocket equation, every bit of extra mass cuts into the vehicle's delta V. In other words, its ability to change speed, which forces you to burn more fuel or sacrifice payload. And for missions that need maximum payload efficiency, like hauling hundreds of tons to lunar orbit or Mars, that dead weight adds up. With every flight, you're potentially losing a few extra tons of cargo or equipment just to offset the ring's mass. Now, Elon Musk hasn't officially revealed the weight of the version 3 ring yet, but based on its design, it looks pretty comparable to the previous version, somewhere around 9 to 10 tons. That's no small number. Second, there's the issue of flexibility, and that's a big deal. Starship isn't built for just one mission. It's meant to take humans to the Moon, to Mars, and help set up orbital fuel depots. A permanently attached hot staging ring could limit that flexibility and drive up development costs. Why? Because instead of using a universal super heavy booster with swappable parts, SpaceX might have to build separate versions for each mission type. In contrast, a removable or interchangeable ring design would allow Super Heavy to easily switch between different mission configurations. That's faster, cheaper, and way more adaptable. Imagine a modular ring system where parts of the ring can be added or removed depending on the mission, without redesigning the whole structure. Even more futuristic, what if the ring had built-in sensors and smart systems that could auto-adjust its configuration in real time? That kind of setup would cut down the need for hardware changes altogether. So, looking ahead, it's likely that not every Super Heavy will come with a built-in hot staging ring. Some may have them, some may not, depending on the mission, to keep the system as optimized and flexible as possible. In the grand scheme of things, those downsides are minor compared to what Starship gains. And that's exactly where SpaceX's mindset shines. Unlike traditional aerospace programs that avoid risk, SpaceX embraces it, testing, flying, and refining constantly. They installed the hot staging ring just months before Flight 2, flew it, gathered real data, and started improving the system in real time. NASA, SpaceX's main partner on Artemis, acknowledged the value of this innovation, with some of their engineers contributing analysis to the design. Analysts from Wired, Aviation Week, and others have pointed out that those early flights proved this concept can work, even at this massive scale. Hot staging, while inspired by old Soviet rocket designs, is now being reimagined for the modern era. This isn't just a performance upgrade, it's a shift in how rockets are designed. Instead of a clean stage separation, SpaceX went for a bold but more efficient solution. And in the future, as hot staging becomes the standard for Starship, its impact could ripple across the entire space industry. Other super heavy rockets might adopt similar designs. Missions that once seemed impossible could suddenly be doable, and hauling bigger payloads per launch might reshape the economics of space altogether. If Starship pulls this off, if hot staging becomes part of its routine, it won't just be a technical win, it'll be the revival of a powerful Soviet-era idea, scaled up and modernized to shape the future of humanity's journey into space. With Starship Flight 10 expected between the 20th and 25th of this month, we could be looking at a historic flight, marking the beginning of Musk's bold and crazy vision. Flight 9 is clear proof that Starship version 2 is seriously flawed. Despite SpaceX's all-out efforts to address the issues behind the explosions of Starship Flights 7 and 8, Flight 9 marks the third time the spacecraft has suffered the same critical failure, a fuel leak. This recurring issue is raising even more doubts about the current design. So, what exactly is going wrong with Starship V2? And could jumping to version 3 be the smartest move right now? Over the past 5 years, SpaceX has kept a pretty steady rhythm in developing and testing the Starship program. Starship version 1, especially through test flights 4, 5, and 6 in the second half of 2024, did exactly what it was designed for, proving key concepts and steadily improving its ability to survive re-entry and land precisely in the Indian Ocean. These flights showed clear progress and really marked the vehicle hitting its stride. And while the steady progress with version 1 was a welcome sign, it also made one thing clear. If SpaceX wanted to go farther, to do things no one's ever done before, they needed a major upgrade. That's why they rushed out Starship version 2, aiming to fix limitations and push the design further. When it was unveiled before the 7th test flight in January, the hype was sky high, maybe even too high. But once the dust settled, it became clear the upgrade didn't live up to expectations. Just look at Flight 9, it says it all. Super Heavy Booster 14 did exactly what it was supposed to do. Its loss was expected. But the real problem was Ship 35. This is the third time in a row it's exploded mid-air. And in all 3 cases, the root cause was the same, a fuel leak. Which really begs the question, what the hell is going on with Starship version 2? First, we need to take a closer look at what SpaceX actually upgraded in Starship version 2. Besides the redesigned flaps, the most noticeable change in Starship V2 is the increased fuel capacity. By stretching the hull by 1.8 meters and optimizing the cargo bay, the total fuel capacity went up from 1,200 tons of liquid methane and liquid oxygen to 1,500 tons. Next, with the significant increase in fuel capacity, the plumbing system got an upgrade too. One of the key changes is the addition of 4 downcomer pipes, 1 for the sea-level Raptors and 3 for the Raptor vacuum engines, replacing the single main line used in version 1. Let me explain this a bit more clearly. With the new Block 2 design, Starship's fuel plumbing now uses 4 downcomer pipes instead of just 1 like in Block 1. 3 pipes feed liquid methane to the Raptor vacuum, RVAC engines, and 1 shared pipe supplies the 3 sea-level Raptors. This new layout, which debuted on Ship 33 during Starship Flight 7, is more complex to build and requires precise alignment at Starfactory during assembly. Each RVAC line now has its own expansion joint, or bellow, at the top to handle cryogenic temperature shifts. Back in Block 1, all 3 RVACs shared a single bellow below the splitter. With independent lines in Block 2, each engine needs its own. All 4 pipes run from the common dome to the aft dome and are about 10 to 20% longer than in Block 1 due to the 1.8-meter hull stretch. That extra length can increase the risk of pogo effects, pressure oscillations that are especially noticeable in the RVAC lines. In Block 1, the shared pipe for the RVACs help dampen those oscillations. But in Block 2, each RVAC has its own line, so that damping effect is gone. As a result, pressure swings might become more severe due to changes in the system's natural frequency. The 3 sea-level Raptors still share a single pipe, similar to the old RVAC setup. But because these engines run at higher thrust and have different fuel flow characteristics, their shared line could create synchronized vibrations if the frequencies align, especially if the pogo suppression system isn't perfectly tuned for the new conditions. Without additional damping, that could lead to fuel leaks or other mechanical issues. This might actually be the main reason behind the serious leak issue on Starship version 2. The issue was so serious that SpaceX has made multiple improvements to the vehicle since Flight 7. But even by Flight 9, they still hadn't fully fixed the root cause. That's why the best move right now might be to fast-track the shift to Starship version 3. But why is V3 the best path forward for SpaceX? Let's start with the upgrades we can expect. The most obvious change? Size. While Starship V2 stood at about 52.1 meters, V3 is expected to stretch all the way to 70 meters. That's a massive leap. And with that added height comes bigger header tanks. We're talking about an increase from around 10 to 15 cubic meters per tank in earlier versions to possibly 15 to 20 cubic meters in V3. This added capacity matters a lot. It means V3 can support heavier landings, longer missions, and carry more payload. But honestly, size isn't even the biggest deal. What really counts are the internal changes, especially in the tanks and plumbing. The fuel lines will be longer, so they'll need to be made of stronger, more resilient materials to handle higher stress and pressure swings. V3 might also include smarter hardware, upgraded pressurization valves, and advanced sensors, based on what SpaceX learned the hard way with V2. The goal? Catch leaks early, before they turn into real problems. Fixing this issue is absolutely critical. After Flight 9, Elon Musk posted on X, explaining that while Starship V2 did manage to shut down its engines as planned, it lost pressurization in the main fuel tank during the coast phase and re-entry. Why? A leak. Somewhere in the tank or plumbing. Propellant escape, causing a drop in pressure. And that pressure is vital. Without it, the Raptors couldn't get a stable fuel flow, and the ship lost attitude control, spinning out of control and ultimately exploding high above the Indian Ocean. That failure wasn't just dramatic, it was revealing. It showed how even a small leak in just the wrong place can cascade into a total mission failure. And that's exactly why V3 is being re-engineered from the inside out, with tougher materials, better valves, and smarter sensors to stop leaks before they stop the mission. Now, the exact plumbing design of V3 hasn't been revealed yet, but it's possible SpaceX will go for a hybrid setup, maybe mixing shared and dedicated lines, or even adding extra insulation to shield the cryogenic fuel from thermal shocks. Next, let's talk about one of the most important upgrades related to those leak issues, the Raptor engines. As you might have heard, Starship version 3 will come with 9 Raptor 3 engines, a major upgrade over the Raptor 2. They haven't flown on any official missions yet, but they're already the center of attention as SpaceX races to get Starship ready for Artemis 3. So, what's the big deal about Raptor 3? For starters, it's a powerhouse. It's designed to deliver around 20% more thrust than Raptor 2, reaching 280 metric tons, or maybe even up to 300 tons per engine, compared to Raptor 2's 230. That's thanks to a more optimized combustion chamber and nozzle design. But here's the kicker. Raptor 3 ditches the heat shield entirely. That reduces the engine's weight to around 1.5 tons, improves performance, and makes maintenance way easier. Its specific impulse, a measure of fuel efficiency, is also better, climbing to about 350 seconds in vacuum. That's a big deal for on-orbit refueling missions, which Starship V3 is built to handle. And speaking of handling, Raptor 3 isn't just about brute force. It comes with a smarter thermal control system, built to suppress pogo oscillations, a vibration problem caused by unstable fuel flow. That was a major headache on V2. To fix that, SpaceX is adding new sensors and pressure valves that help keep propellant flowing smoothly. That could go a long way in preventing the kind of leaks we saw during Flights 7, 8, and 9. Also, Raptor 3 features a streamlined design with fewer components. That makes it easier to integrate into Starship V3 and reduces the chance of early engine shutdowns, like what happened on Flight 8. All in all, Raptor 3 is a huge leap forward in both performance and reliability. And with 9 of these engines and 2,300 tons of propellant on V3, this upgrade could be the key to keeping SpaceX on track for Artemis 3, bringing humans back to the moon as early as late 2027. And the best part? We're already starting to see some solid visual signs that Starship V3 is closer than ever. On April 9th, a photo surfaced showing the nose cone of Starship 39 inside the Starfactory, just before final assembly. The first thing that caught everyone's eye was how smooth and shiny the surface looked, almost flawless. Gone were the obvious weld seams, rough joints, and uneven surfaces that were common on earlier versions. This major upgrade comes thanks to SpaceX's new robotic laser welding process. Laser welding means cleaner, more precise, and way more consistent build quality. The improvements seen on Starship 39's nose are a strong sign that SpaceX is moving into the early stages of Starship V3 production. In late April, a spotter at Starbase also spotted Ship 39's methane header tank inside the Starfactory. And to top it all off, a recent photo showed a Raptor 3 vacuum engine, clearly marked with serial number 16, being transported in McGregor, Texas. This engine comes with a noticeably wider nozzle, tailored for operations in the vacuum of space. Its design is cleaner and more streamlined than ever. What really stands out is the lack of external heat shields, weld marks, and bolts that were typical on earlier versions. During his recent Mars presentation, Musk also gave us a glimpse of something truly exciting, a test video of the upgraded Raptor V3 engine. And honestly, it was stunning. That bright blue flame blasted out with incredible force, a total contrast to the engine's clean, minimal design. It's the kind of raw power that makes you even more hyped for the first Starship launch powered by this next-gen engine. Looking at all these signs, I really believe Starship V3 is about to take over from V2, and it could be the game-changer that finally meets Musk's latest plans for Mars. Also in the presentation, Musk said that the rocket launch later this year could make life multi-planetary. That's a huge hint. It could mean that by the end of this year, the upper stage of Starship might actually get caught by the chopsticks on the launch pad. Or even more exciting, Musk might be planning a direct Starship flight to Mars. Even more ambitious, he revealed plans to send 5 landers to Mars in 2026, each carrying 10 tons of cargo, including robots. And starting in 2028, SpaceX aims to launch hundreds of flights, delivering a total of 150,000 tons of cargo to the Red Planet. To stay connected with Earth, Musk plans to launch hundreds of next-gen Starlink satellites. Under ideal conditions, they could beam data back to Earth in just 3 minutes. That's a whole 1.2 minutes, faster than the fastest one-way signal transmission from NASA's Mars rovers like Perseverance or Curiosity. Finally, SpaceX is ready to unleash Mechazilla at 100% power by the end of this year. The Starbase launch tower was built to not just launch, but catch both Starship and Super Heavy mid-air, a feat of engineering straight out of sci-fi. Yet, after 9 test flights, it's still waiting to flex its true power. But Elon Musk didn't keep us waiting long. He's already revealed that after just a few more test flights, Starship will attempt the craziest catch like never before. So, what exactly did he say? And how will SpaceX change the game with this landing technique? From NASA's golden age with the Apollo missions to today's era of cutting-edge rocket tech, space agencies have come up with all kinds of clever ways to bring crewed spacecraft, or upper stages, safely back home. Take the Apollo missions, for example. The crew capsule splashed down in the ocean using parachutes, and that old-school method still holds up. Just look at SpaceX's Dragon. It uses the same idea, just with modern upgrades. Now, if we're talking about landing on solid ground, Soyuz and Boeing's Starliner are the go-to examples. These capsules are designed to touch down gently on land, using parachutes and retro rockets to soften the blow. But let's not forget one of the most unique landings ever, the Space Shuttle. That thing came down on a runway like a regular airplane. Totally different vibe. And now, Sierra Space is bringing that idea back with Dream Chaser, their sleek little space plane that also lands on a runway. On the other hand, if the upper stage isn't reusable, like the SIVB stage from the Saturn V rockets used in Apollo, NASA had a couple of smart tricks. Sometimes they pushed it into a heliocentric orbit. Other times they crashed it into the moon on purpose. Yeah, seriously. In 1969, they smashed one into the lunar surface just to study moonquakes. Plus, it helped avoid leaving junk in orbit. Fast forward to today, Elon Musk and SpaceX are doing something similar. If the Falcon 9's upper stage isn't coming back, they'll either let it burn up in the atmosphere or toss it into a graveyard orbit. Same with the Dragon capsule's trunk. Once it's done its job, it gets jettisoned and burns up on re-entry. But there's one landing method that, I'd bet, no other space agency in the world has ever seriously tried. Catching a spacecraft right on the launch tower it took off from. Yes, that's exactly what SpaceX plans to do with Starship. After a controlled descent, it won't land on a pad. It'll be caught midair by a pair of giant mechanical arms called the chopsticks. At one point, Elon Musk said SpaceX would need to nail at least one more successful ocean landing of the Starship upper stage before even thinking about attempting that insanely complex tower catch. But for a bunch of reasons, possibly the FAA investigations, or all the upgrades and tweaks they've been making to the vehicle, that plan's been pushed back. Still, Musk hasn't dropped the idea. In a comment on an X video showing a Starship landing, he said, "Later this year, if fate smiles upon SpaceX, the ship will be caught by the tower, just like the booster." In a more definitive move, During a recent presentation on his Mars plans, Elon Musk revealed an impressive 3D animation of Starship landing on Mechazilla, and once again reaffirmed the plan to catch a ship later this year, possibly within the next 2 to 3 months. That statement gives us a more solid timeline. And since we're already halfway through the year, it really puts things into perspective. But honestly, it still feels a bit late compared to what many of us expected, myself included. If that timeline holds, we might not see the tower catch attempt until something like Starship Flight 15 or beyond. Here's why that makes sense. As of now, Flight 13 is expected to use prototypes Ship 39 and Booster 18, possibly the first pair from the upgraded Starship version 3 line. Since this is a major hardware overhaul, it's unlikely SpaceX would risk something as complex as a tower catch on their very first launch with it. Same goes for Flight 14. If it ends up being the second mission with V3 hardware, it'll probably be used to test and validate upgrades, fix any issues found in Flight 13, kind of like what they did with Flight 9, which focused heavily on experiments and fixing the harmonic resonance problem. So, yeah, that would make Flight 15 a pretty reasonable candidate for the first real shot at catching Starship with Mechazilla, just like I predicted. And this isn't something SpaceX can just wing. Catching Starship is a whole different beast compared to catching Super Heavy. To pull this off, they'll need to deal with a bunch of extra challenges. First off, Starship isn't just any rocket stage. It's a full-blown orbital spacecraft, packed with sensitive systems like aerodynamic flaps and heat shield tiles. These components don't just have to survive a tougher ride, they've got to perform flawlessly through every single stage of the mission. It has to make it all the way to orbit to do its job, whether that's deploying Starlink satellites or some other payload. On the way up, it deals with massive stress. Once it's in space, the upper stage is exposed to brutally cold temperatures. We're talking minus 270 degrees Celsius, close to the temp of liquid nitrogen. At that point, materials like stainless steel or ceramic tiles behave very differently. For example, 304L stainless steel gets stronger, its tensile strength increases, but it also becomes less ductile, meaning it's tougher but more brittle. That's a big deal when it comes to how the ship handles stress and strain in orbit. Then comes re-entry. The heat shield has to endure temperatures between 1600 and 2000 degrees Celsius as Starship slams into the atmosphere. That's where the ceramic heat shield tiles come in. But here's the catch. If even one tile near a weak spot pops off, or if there's too much thermal stress between materials, especially around weld points, cracks or deformation can happen. And that's risky, whether the welds are done by hand or robots. If Starship makes it through that fiery descent, which is no small feat, it still has to nail a controlled descent and align itself perfectly for landing. And then comes the boldest move of all, getting caught by Mechazilla. Even if everything else goes right, catching Starship with those giant chopstick arms is a whole different level of complexity. The shape, the way its mass is distributed, and its flight profile all make it way harder than catching a booster. It's like trying to catch a flying brick that's coming down from space, precisely. But to be honest, this method carries a fair bit of risk. There's potential for error on both sides, the ship and Mechazilla. If Starship fails to align perfectly with the chopsticks, maybe because of a guidance glitch, a sensor failure, or thermal stress that warps the catch points on the vehicle, Mechazilla might not be able to get a solid grip. And if that happens, well, it's going to be a bad day at Starbase. We're talking about a possible explosion, shock waves, and debris flying everywhere, damaging the launch pad infrastructure, maybe even severely impacting the tower itself. Of course, that's the worst-case scenario. The SpaceX team likely has contingencies in place. If the ship shows any issues during re-entry, like if a Raptor engine fails to reignite, they'll probably ditch the tower attempt and just go for a splashdown in the ocean. And in an absolute emergency, they could even trigger the FTS, the Flight Termination System, ready to destroy the vehicle before it poses any serious risk. The thing is, no other space agency on the planet has ever attempted something like this. So for SpaceX to catch the upper stage of Starship with a Mechazilla, it's going to take some serious prep, technically, logistically, strategically, over the next few months. But if they pull it off, they won't just be the first, they'll be the only ones to have ever done it. And more importantly, this way of landing, it could completely change the game. Just one successful Starship catch, that's all it'll take. With that single moment, Elon Musk could prove to the entire world that this giant spacecraft really is fully reusable. You know, building a full Starship stack, booster and all, costs tens of millions of dollars. But if it's reusable, the cost per launch could drop to just $2 to $3 million. That's mostly just for the liquid methane and oxygen, plus some maintenance. Just one successful catch, and Starship won't have to endure the brutal impact forces of landing on a pad or splashing down in the ocean. There's no risk of fuel leaking into the ocean, no harm to marine ecosystems. It's a much greener, more environmentally friendly approach to spaceflight. And beyond the environmental perks, there's a major logistical upside too. Once Mechazilla successfully catches Starship's upper stage, it can place the vehicle right back onto the ground within minutes, just like it does with Super Heavy. The moment those chopsticks grab the ship, it's a quick lift, a ride back on the transporter, and boom, Starship's back at the launch site. No need for complex recovery ops like with Falcon 9 or Dragon, where the rocket has to be fished out of the ocean or hauled back from a remote landing pad. That stuff can take hours, sometimes days. This question market saves time, cuts costs, and ramps up the flight cadence, all crucial for keeping Starship's ambitious launch schedule on track. But here's the most important part. Mechazilla gives SpaceX the ability to launch multiple Starships in quick succession, a game changer for complex missions like Artemis, which aims to land astronauts on the Moon or future cargo deliveries to Mars. Just imagine, a Mars colony might require hundreds of launches to deliver hundreds of thousands of tons of supplies. Mechazilla shortens the turnaround time between launches from several weeks to just a few days, or even less. Why does that matter? For long-duration missions like a 6-month journey to Mars, launch windows only open every 26 months, and they last just a few weeks. Mechazilla's rapid launch capability means SpaceX can maximize those narrow windows and avoid missing critical opportunities. Of course, that long-term Mars vision is still pretty far off. Realistically, it'll take SpaceX another 10, maybe even 20 years to get there. So, let's talk about something more immediate. One of the most anticipated milestones coming up is orbital refueling, a critical step for long-duration missions to the Moon and Mars. It was originally targeted for late this year, but chances are it could slip into early next year. Why? Because a successful Mechazilla catch could give SpaceX the confidence and operational readiness needed to pull off something as complex as docking and fuel transfer in orbit. Next up, the Moon. SpaceX plans to launch an uncrewed lunar Starship as early as next year, paving the way for NASA's Artemis missions with astronauts in 2027 and 2028, humanity's long-awaited return to the Moon after more than 50 years. At the same time, SpaceX is already pushing toward Mars, aiming for an uncrewed mission within the next 2 years, and possibly a crewed flight just 2 years after that. In the end, it all comes down to one new way of landing. One bold move that could reshape the entire future of SpaceX. With Mechazilla, Elon Musk isn't just upgrading a rocket. He's rewriting the playbook for everything that's ever been done in spaceflight. We once watched with awe as Neil Armstrong took that first historic step on the Moon. Now, it's time to look ahead, to Musk, and the moment when humanity might take its very first step on Mars. That moment could be even more powerful, more emotional than anything we've ever seen before. While we're still trying to figure out what went wrong with Flight 9, Elon Musk already drops the launch date for Flight 10. And, yeah, it's way sooner than you'd think. So when? Can the SpaceX team meet this Elon Musk's time? The Starship Flight 9 recently left us with mixed feelings, a spark of hope, a touch of disappointment, and a bit of sadness. But, no matter what, every result is a priceless lesson to help SpaceX build the rocket's future, following Elon Musk's motto, test fast, fail fast, learn fast. That's why he didn't waste a second and immediately announced a new launch schedule for next month on X. He said, launch cadence for next 3 flights will be faster, at approximately 1 every 3 to 4 weeks. This means Flight 10 isn't the only one on the fast lane. The next 2 missions are also being lined up for the quickest turnaround possible. If that's the case, Flight 10 could happen around June 20th, which happens to be World Refugee Day. Flight 11 might follow on July 15th, and Flight 12 could lift off in the first week of August. Of course, That's just my prediction based on what Musk said. But overall, it feels like he's rushing these next 3 flights for a reason. Maybe to catch Starship with Mechazilla, test the new Raptor 3 engine, or even unveil the very first flight of Starship version 3. Whatever it is, something big might be coming. With that in mind, all eyes are now on Flight 10, the next big step that could really prove how far they've come. At this point, Ship 36 is shaping up to be the most likely choice for the upper stage. As for the booster, B-16 looks like the frontrunner, though B-15 is still in the mix, especially after its standout performance during Flight 8. SpaceX may be tempted to reuse B-15 as further proof of reusability, and to attempt maneuvers that B-14 never quite pulled off. Let's zoom in on Ship 36. It's the 4th Starship Block 2, and completed stacking on March 12th at Mega Bay 2 after 41 days of assembly. This ship is notable for being the first to have both its payload bay and nose cone built inside the Starfactory, rather than the high bay like previous builds. By April 26th, most of its thermal protection system tiles were in place. Unlike Ship 34, which only used tapered edge tiles near the nose, Ship 36 features them across its entire body. The gaps between the tiles were also filled with secondary ablative material, a clear sign of an upgraded heat shield design. It was then moved to the Massey site for cryogenic testing on April 27th and returned to Mega Bay 2 just 2 days later to continue prep. Then, on May 21st, RVAC engine number 524 showed up at the same facility. It was initially thought to be for Ship 35, but now it looks like this engine is actually meant for Ship 36. Now here's something interesting. There's a new road closure notice on State Highway 4, scheduled from 10 p.m. on May 28th to 4 a.m. on May 29th. The affected area stretches from the factory to Massey's test site, exactly the route used to move Starships. It's a 6-hour window, but the notice says the closure will only last about 2 hours during that time. So, if everything stays on track, static fire testing could kick off in just a couple of weeks, a big step forward for Flight 10. And personally, I still think Booster 16 will be the one to fly with Ship 36. Just look at its journey. B-16 finished stacking on December 26, 2024, after 71 long days at Mega Bay 1. It crushed its cryo test at Massey's on February 28th, then came back for the final touches. Now, it's fully loaded, all 4 grid fins in place, those massive steel panels welded tight, each about 7 by 3 meters. And here it stands, ready, just waiting for that moment, waiting to join with Ship 36 and turn Flight 10 into something unforgettable. But even with all that momentum, there's still one thing that bugs me. Based on the issues we've seen in previous flights, it's almost certain the FAA will require another investigation into this latest explosion. So, why is Elon Musk so confident about lining up 3 launches so close together, even though the FAA usually steps in after any major incident? Let's take a closer look at what's really going on. Take Flight 7 in January 2025 and Flight 8 in March. Both missions ended in vehicle explosions, triggering FAA investigations due to potential risks to the public and the environment. After the Flight 7 mishap, caused by an oxygen fuel leak near the engine firewall, SpaceX submitted a mishap report and still got the green light for Flight 8 in March, even though the investigation into Flight 7 was still open. Then again, after Flight 8, SpaceX filed its mishap report on May 14th, and the FAA approved Flight 9 just 8 days later, on May 22nd. That shows SpaceX is not only providing complete and timely data, but also convincing the FAA that the risks have been addressed, whether through design upgrades, system improvements, or changes in operational procedures. And part of this flexibility comes from the FAA itself. Their process doesn't always require the entire investigation to be wrapped up before approving the next launch, as long as the operator meets the minimum safety criteria. In fact, in May 2025, the FAA approved a major increase in launch cadence at Starbase, raising SpaceX's launch limit from 5 Starship flights per year to 25th. That move reflects the FAA's growing confidence in SpaceX's ability to manage risks and continuously improve their systems with each flight test. It's a proven pattern, and that's exactly why Musk feels confident enough to roll out such an aggressive launch schedule. He knows SpaceX can implement corrective actions fast, just like they did after Flight 8, and keep pushing forward without long delays. Looking at it from another angle, Musk is pushing Starship hard to hit major milestones, like sending astronauts to the moon for NASA's Artemis 3 mission, planned for 2023-2027. It's about rekindling that heroic Apollo spirit and ultimately making human missions to Mars a reality, something we've only dreamed of or barely dared to imagine before. To hit these big goals, SpaceX needs to ramp up test flights to refine the tech, especially re-entry and landing capabilities. Publicly announcing a tight schedule of 3 launches in quick succession might be Musk's way of putting pressure on the FAA, while building confidence with the public and partners that SpaceX's progress is on track. Additionally, Musk is currently a close advisor to President Donald Trump and is leading efforts to reform the U.S. government, focusing on cutting red tape, reducing corruption, and eliminating budget waste. He's openly criticized the FAA for its outdated regulatory structure, and even called for its leadership to resign. With this political influence, Musk likely believes the FAA won't delay SpaceX launches for long, especially when he has the means to sway regulatory decisions in his favor. So, basically a launch every 3 to 4 weeks? That sounds pretty reasonable. But it seems that Musk diving too deep into politics hasn't exactly helped Tesla or SpaceX thrive. Recently, several of Tesla's facilities have been deliberately targeted, test vehicles set on fire, windows vandalized with spray paint, supercharger stations burned, and even worse, a Tesla dealership in Tigard, Oregon was shot at over a dozen times, damaging both cars and the building. Now, though, Musk is stepping back from the political spotlight and jumping back into SpaceX full-time. And because of that, the whole team is fired up. There's a new sense of energy, of hope, that his renewed focus might finally give those upcoming test flights the push they need. Flight 9 didn't go as planned, sure, but Musk's staying positive and determined. After being wrapped up in politics for a while, he's back where he belongs, leading SpaceX with that same unstoppable optimism. So, let's rewind a bit and take a closer look at Flight 9. Musk recently shared more details about what went wrong with both Booster 14 and Ship 25. He said, leaks caused loss of main tank pressure during the coast and re-entry phase. Lot of good data to review. That's right, Ship 35 once again suffered a leak, either from liquid oxygen or liquid methane, in the section just above the engine firewall. It's the same issue we saw on Flight 7 and Flight 8. But this time, Musk didn't mention anything about harmonic resonance, probably because the root cause hasn't been identified yet, at least not so soon after the flight. What he did confirm, though, is that the leak caused a loss of main tank pressure during the coast and re-entry phase. That's a big deal. These tanks carry super-chilled propellants, liquid oxygen below -180 degrees Celsius, and liquid methane below -160 degrees Celsius, stored under intense pressure. At those extremes, even the smallest imperfection in a weld, valve, or insulation layer can be enough to trigger a leak. And it gets worse during the coast and re-entry phases. At that point, Starship isn't just holding pressure, it's also enduring violent shaking and brutal thermal loads. As it slams back into Earth's upper atmosphere, temperatures can soar to 1,400 degrees Celsius. These combined stresses can further weaken critical joints or insulation, turning small vulnerabilities into major failures. That's likely what happened with Ship 35. But despite these setbacks, SpaceX still hit some major goals with Flight 9 and gathered solid data. First, Booster 14, which also flew on Flight 7, successfully launched again and completed a full burn with all 33 Raptor engines during ascent. This marked the very first time SpaceX reused a super heavy booster, a huge milestone toward fully reusable launch systems. The booster separated cleanly from Ship 35 after pushing it into low Earth orbit, and even completed an engine reignition test, proving the system still works well after reuse. As for Ship 35, it reached a big milestone by hitting its scheduled engine cutoff, a major step up from IFT-7 and IFT-8, where both ships were lost before finishing their burns. The goal here is to shut engines off exactly on time, preventing wasted fuel or overshooting the target orbit. This optimizes performance and saves resources for later mission stages, a crucial improvement for future Moon or Mars missions. Moreover, SpaceX also tested some new metal heat shield panels on Ship 35 at a few key spots. These panels come with built-in cooling systems to help manage temperatures during re-entry. Surprisingly, they performed really well. Musk confirmed that none of the heat shield tiles were lost or seriously damaged during ascent this time. Back on Flight 6, SpaceX saw issues with ceramic heat shield tiles falling off or getting damaged during re-entry. So, this improvement shows their new heat shield design is making a real difference, a big step forward from lessons learned on earlier flights. All right, those are some of the key insights SpaceX managed to gather, and there's probably even more behind the scenes. But for now, let's wait and see what the